Yo, 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 what's good?
Hey CJ, good afternoon. It's going good over here. How are you?
I'm okay, and that's good to hear.
Awesome, awesome. Hi, everybody. Good afternoon. Wow, I just realized it's pretty dark in my screen, but welcome everyone. Back into pre-calculus. Happy Wednesday. It's also is today the last? Yeah, I think this might be your last class. I do have office hours today though, right after, in case anyone wants to check in on anything. But let's go ahead and do our check-in question, y'all. And then I could, double check on attendance and all that. Our check-in question today is to just take some time right now. Think about what you're grateful for today. Just anything that you're grateful for today. And then I'll take a look in a second. Thank you so much for your sharing and what we're grateful for. All right, I see a few things there into the chat. All right, we got Wi-Fi. Yeah, sometimes that Wi-Fi is not guaranteed. I agree with you. So yes, on the Wi-Fi, internet and friends. Yeah. Yep. Having good cash. That's quite an indeed. It's a blessing. Not everyone has money. Life. Yes. Just our life itself. Oh, the mom made breakfast. That's nice. Having the internet. I agree. Friends and family and my bed. I feel like yes, definitely the bed part. I am really with that one. Friend, family, clothes, yeah, clothing and money that I woke up. Every day, just being able to wake up is a blessing in itself. We got friends and family, access to school. That's nice, yeah. That we're able to at least get some education, and that's really good. We got family and friends, the internet. We got friends, food, family, and bed. These are all really awesome things to be grateful for. All right, let me go ahead and double check who we have here and who we're missing. Um, okay, so correct me if I'm wrong, but I think I'm missing Tori. I'm also missing Denise. Rebecca. Also missing Rebecca. Again, correct me if I'm wrong. Um, what is that? Are we missing Kyla? You know that's I'm trying to double check here. Kyla. No, so we're missing Kyla. Um, Leon, Celia, and Sincere. Let me know if that's correct, y'all. So that's who I'm missing. And if you're friends with them, if we could shoot them a text so that we could get them into class, that would be super, super great. Again, let me know if I marked someone accidentally absent. Let me do it one more time. So we're missing Tori, Denise, Rebecca, Kyla, Leon, Sincere, and Celia. Let me go ahead and hit submit there. Y'all, thank you so much for sharing your gratitudes today. It's really nice to just be aware of that. It already like lifts our spirits to just be grateful. All right, let's go ahead and jump into our agenda. So we have another day with possibility of credit. I already entered in yesterday's credit. You were able to check that out in Power School. Oh yay, we just let everybody. Awesome. Let me fix up the attendance. Okay, so here's our agenda today. So we just had our attendance check, and we're gonna continue. Well, no, I'm sorry, we're not doing no group exploration. So we're doing the exploration with limits. That's what we're doing. Give me a sec. Let me just adjust that so it doesn't confuse anyone. Oh, sorry. There we go. This is our true thing that we're doing there. Ooh, and I see some slides. Awesome. Okay. We just had attendance check. We're going to be continuing to learn what limits are. by following along with our notes and continuing to interact on the Padlet as our credit. And we're going to continue with limits, and then we'll check out today. As a reminder, asynchronous number one has been posted. This one is due tomorrow. So again, because we just started our module this week, mm, I'm not giving you like two asynchronous assignments. Hold on a second. Oh, we got Rob coming. Awesome. Yep, I got you. Don't worry. You're marked present. Hi, Rob. Welcome. I'm just going over the agenda and making sure I'm letting in the correct people. Also, make sure I. Okay. Let's see. Let me just make you Rob co-host. If y'all can check, because I've been sending a few of you just some messages there. I don't know who. Okay, let's go ahead and continue, everyone. All right, so we're gonna go ahead and jump into where we left off, and I could go ahead and kind of like explain the new way that we're actually gonna follow along with our notes. And remember, what you want to do is you want to go to Google Classroom, and when you go to our period 6 classroom, you should see the very first top post right here. It should say quarter 3 day 2 notes. You're going to click on the link, and it's going to take you to where I'm at here in my presentation. And we're following along, and you're making a copy of the slides and then putting down your notes. So that's what we're doing at the moment. And then, yeah, so there was a question. We make a new copy every time we have your class. Yeah, so, and how you can organize your stuff is you can just toss them into a folder on Google Classroom, and it's going to be all together. That way you don't lose access. Another reason for this is, again, there's no point in you copying down something that you already have access to. So it does take up some time. And if it's already there for you, you just pull up, open the slides, and you could take a look. So that's the reasoning for that. Kind of like there is, like during virtual time, it's not as effective to copy down, what you see on the slide on a piece of paper. Good, I see a few of us on there. And you make a copy. The reason for making a copy is you want to add annotations by using the little comment box. And okay. All right, so then for those of us who went ahead and opened up the slides, are on slide number 4 right here, and we're continuing our investigation, like exploration that we started off with yesterday. So where we left off is where Benny ended up at while he was walking. So Benny had been said to start right here, and we have that Benny was walking up along this hill kind of thing. Again, y'all, let me remind you too that these bugs are special. They can't fly, they can't jump. So they kind of end up getting stuck somewhere on your graph. So we have to imagine that Benny's walking, walking, and he's going to keep walking until he stops as this gets closer to, and remember, I kind of added this x equals 3. Um, so Benny keeps walking, walking, then he's going to end up right here. And we all saw that yesterday, that height that he ended up with, when it says, how high does Benny think he'll get? That height is the y value because your y usually determines the height, right? It's the vertical distance. So the answer to this yesterday was y equals 5. Does anyone have any like clarifying questions? So this one we walked through yesterday, but I just quickly went over it. Does anyone have any questions about this part 1 and where Benny ends up? We're going to soon make connections to how this relates to limits, but yes. For sure, for sure. Okay, so if we don't have any questions on this, we're going to go ahead and move on to part 2. So part 2 of this exploration, again, if you're following along, you're able to see it here. So now it says Benny's sister's Bertha. So she starts at the point of the curve corresponding to x equals -2. And she's going to move towards the right of the graph. So she's trying to meet up with Benny. So she's going to move towards her right. And then how high does Bertha think she'll get as she gets closer and closer to x equals 3? Question mark. So um, this is the x value, -2. So this, of course, must be Bertha, and it's the only other bug there on our graph. So this is Bertha, and she's going to now walk uphill. She's trying to meet up with her brother, and she's going to stop at the x value of 3. And when she stops there, we need to see how high is Bertha. How high does she get? That means at what y value is Bertha at? So maybe y'all can put your thoughts there in the chat. How high does Bertha get here? Yeah, you guys got it. I see 3 in the chat are saying the y value equal to 1. That's right. Yes. So that's how high Bertha is going to end up getting. So y value of 1 right here, y'all. So that's true. So that's where Bertha is going to end up being stuck at. So she's going to end up at y equals 1. And so because these two bugs can't jump and they can't fly, unfortunately, they won't get to meet up during this path that they found. So they won't meet up, but maybe they'll need to find another kind of function that will allow them to meet up, a function that doesn't have a gap like this one does. So then, how in the world is this connected to limits, like these bugs moving along a graph? Some of you had some ideas when you wrote down on the Padlet the other day. So we're going to check those out in a second. Again, let me see if there's any questions about where Bertha ended up, where Benny ended up. Let me know. Limit to their height, question mark. Oh, so Danny's already, you're trying to make a connection as to what the limit is. So Danny's thinking like, is the limit basically their height, like where they end up at? Maybe. We'll get to see that in a second. Awesome. Let me go ahead and clear up the screen. Clear this up. And again, remember, as you're following along, you highlight, you make a comment as to the answer of where the bug ends up at. Okay, y'all. So we just saw like a bug, like Bertha started on the left side of the graph and then she started walking. There's a specific notation to actually describe her motion using limits. This is actually it. So notice that first off, take a look at both of these and notice what's different about them first off. And then definitely take some time to read the description at the bottom of the limit expression. So I'll leave this and then I'll start to explain it. I'm going to turn on a light on my side. Give me a second. Okay, so yes, actually what we were just doing right now with Benny and Bertha is you all were finding limits. So we were already doing it. We just now need to know how to connect it to this special notation we were looking at. So take a look here. So the only difference between these two expressions is the fact that, let's see in the chat, hold on, let's see if anyone said anything. Yeah, okay. Oh, okay. Yeah, so somebody just messaged me private. You should do it out to everyone. We can see your ideas. But yes, someone just said the only difference between the two is the plus or minus sign. That's correct. So I'll circle it for you if you all didn't notice this. So it's this minus right after the a value, and then there's a plus right after the a value. Now, what is the a value? So if you want to connect it to the prior Benny and Bertha problem, the a value was the x value that they had to stop at. And those bugs in the last slide, they had to stop at the x value of 3, both of them. So again, how you read this one is the limit as x approaches a from the left. So one of the bugs was approaching 3, starting from the left-hand side of the graph. That was Bertha. And the other bug, the limit as x approaches a from the right, that was Benny. He was approaching 3, the x value of 3 from the right-hand side of the graph. So this is how these two expressions connect to that. But don't worry if you're like having a hard time visualizing this. We're gonna in a second go to the next slide. I'm just gonna pause here for any questions though on this part. So this is just an intro to this notation and we're gonna make connections right now to Benny and Bertha and their movement. Welcome if you just came in. Let me go ahead and update our attendance. Sorry, there was a question. I'll try to get to that in a second. Okay, let me go ahead and clear this screen. All right, so now maybe some of you are already ahead of the game, right? If you have a copy of my slides, hey, you're free to take a look at what we're moving on to, but because we should all have this open. But okay, now let's connect Benny and Bertha's movements to the limit notation now. So yes, Danny was saying something in the chat like he thinks that the limit was connected to how high the bugs ended up or their height. Yes. So that's basically what's up here. Let me just underline that. You're asking yourself what y value is our function approaching. Function, you can think about what y value is our bug approaching into an equivalent fashion to kind of connect these bugs there to this limit expression. So yes, we're looking at how high the function is at or how high the bug went. And let's go ahead and connect the limit notation to, and this was down here was Bertha. So remember Bertha was down here. Bertha started right here, right at the bottom. And Bertha was walking up this hill and she had to stop at the X value of 3. And she ended up at the height of 1. as we just saw. So how we would write this in equivalent limit notation is going to show up right here. So pay attention to what comes here once this little slide bar goes away. There we go. Slide bar is still there, but so as you can see, there we go. This is how you would write Bertha's movement. The limit as x approaches 3 from the left, notice there's a little minus sign after the 3, of my function, and we're going to call this function f of x, equals the height of 1. Notice how we can make connection to her movement with the expression. Let me just pause and see if does anyone have any questions about the limit expression we just made for Bertha's movement. All right, let's see the chat here. And yeah, I mean, someone is asking, like, is it okay if we take notes in our notebooks? You could totally do that, of course. Totally. And then you have a copy of the slides. So if I do move kind of quickly, you could just, open up your copy and just make sure you take little notes. Another thing we could do, I'll show you another way you could take notes if you don't like the comments method. But yeah, the thing is, I just didn't want to like start collecting notes. Because I felt like for most of us, I don't know, it's not fair because then most of us won't learn that way, but I could understand if you'd like to write down notes. That's perfectly available to you. Like, for example, it's going to be hard to show this like line motion, right? So remember, this was Benny. Benny's the one we did yesterday. Benny ended up at a height of 5 yesterday. So he ended up at a height of 5. He started from the right-hand side of the graph. Let me explain how I know which one is right and left, by the way, y'all. How I know which one is the right-hand side and the left-hand side is because first off, we have to know where the bugs are going to stop. They both have to stop at the x value of 3. So what I like to do is I like to just draw like a little vertical line down to where the x value of 3 is at. Once I've drawn that down, I start to label it. So I know that on this half of my graph is the left-hand side, because that's your left, right? If you have your hand here, it's the left. And then on this side of the graph, it's my right. So that's why Bertha's movement is connected to the left-hand limit notation that you see down here. That means there's a minus after the 3. So that's the reasoning there. And so for Benny, we're going to see his notation come up right here. So the limit as x approaches 3 from the right, because he started on the right-hand side of the graph, we're going to be writing a plus. Take a look at his. But notice how his limit is equal to 5, because that's how high he ended up at. Take a look at that. Feel free to ask any questions right now. And again, I mean, you could add little arrows here, like the Benny's starting on the right-hand side. That's why his sign after the number, you could call it like a subscript or something, is going to be positive. Bertha's is negative. Depends on which side of the graph they kind of started their motion. I'm going to go ahead and clear my screen, and we're going to jump into today's first Padlet participation. Oops, I'm trying to reply to, can't reply. So I'm going to go ahead and clear my screen. I see a message there. It won't let me reply. Okay, there we go. Yay, someone said I'm starting to understand how it works. That's awesome. And all right, so this is our first Padlet. Maybe some of you are, for those of, ooh, oh, it's right here. So for some of you who are ahead, usually when I have a pause and Padlet time, I'll put the link down here in the notes section. And the thing that I was going to show you all too is that you can also take notes here, like down in this section, like put yourself little bullet points of the motion and like why is Bertha's minus and why was Benny's plus. Like you could add yourself little comments in the slide section. So that's another way you could take notes if you don't like highlighting and making comments. Okay, so I'm gonna go ahead and put the Padlet into the chat. And we're gonna go ahead and answer our first check-in question there. This is gonna be on 1, 2, 3, the fourth column. Yay, we already kind of know what to do. So we're in the fourth column. So the question is, using limits in your explanation, why don't Benny and Bertha meet up, right? They weren't able to meet up. Try your best to use limits when you explain this, but if you can't, that's okay. Just try your best to explain why Benny and Bertha don't meet up. Again, you want to put your name or initial for credit. And if you click on the visual I entered here, you can make it nice and big, but it's basically what's on our slide that you should have open. So this is on our slide. Let me go ahead and put the directions in the chat. So we're on the fourth column on the Padlet. And I'll give some time. Again, name or initials. Let me make sure I put that in the directions. I gave credit yesterday for our participation. So I'm gonna also enter some today. I definitely want to make sure I give like even like active classroom engagement some credit because we have some good stuff going on. I don't want to just base it on like asynchronous. All right, we got 3 so far. Let's keep it going, y'all. I'll give you some time though. Go ahead and process this. But just a reminder, name or initial, please. We're getting more and more comments. Awesome. Let me give you all a minute and then we'll check out what y'all are thinking. Keep going. I see some of us are still writing there your contribution. Oh, wow. These are very deep. So I can't wait to read some of these very, very deep understandings that I'm seeing here. All right, I'm going to go ahead and take a look at what y'all are saying because we're going to continue to think about like what does it mean when the bugs don't meet up and what does that mean for limits. Well, yeah, so they can't meet up because one is higher. Yes, that's true. They start on different heights and two different sides of the graph. Yeah, like the graph looks visually disconnected. They don't meet up because both sides aren't the same number. Yeah, one is not equal to five. Different heights, not the same number. Yes. See how we're like saying the same understanding but in different ways? Really, really cool. I think the two books don't meet up because the Y values are different. Yup. And I like that you're including math language there, Y values. Yes. Then we got Benny and Bertha don't meet up because the graph had limited points that did not meet, or the graph is not meant to meet, right? It's not like a straight line. Supposed to think there's two different lines that have no meeting point. Yeah, like I think that was also mentioned before. It looks like two separate graphs, huh? Like a broken up piece of graph. And yeah, this one's like a straight up good understanding. They don't meet because one is higher than the other. Again, not higher than the other. They have a different starting point. They'll never intersect. One is higher than the other. So look at this. Very common understandings here. And then they don't meet up because they start on the opposite of the graph as an understanding. Ooh, okay. Look at GD right here. Says they don't meet up because the limit is one for Bertha and the limit can't go up. Also, she can't fly to Benny and see him. They're both limited due to the Y value. I like how the limit was added in. Oop, we got another limit. They don't meet up because they start at different heights and the limit, so they aren't able to meet up at the same place. I love how like we're already comfortable using that the new word limit. And okay, yes, limits here. Limits were three. So like they had to both stop at three, but their height is different. I love that. Left side the height is one, right side the height is five. Very, very clear. They start off at a different height. And this says when you add the two different values, the difference between them is the same. So Benny and Bertha can't meet. Wow. These are all so super deep. And I think reading it, it's gonna like stick more in our minds. Yeah. But all right. Awesome, y'all. Thank you so much for those your pausing and thinking about this. Let's go ahead and now actually do some practice. So this is what actual problems will look like even on conicotomy. So this is now application. So we were just talking about limits with bugs. Now, what if you have a graph that doesn't have bugs on it? How are we going to apply this? So we're now on slide number 8. So for this one, again, you can make yourself little notes at the bottom for the answers, and or you could comment like so, like make yourself a little comment as you're annotating. Again, if you have a preference for writing down your notes, that's perfectly fine as well. All right, so now this is the stuff you're going to see in your Khan Academy practice. But not to worry, because if you go on Khan Academy, if you click Get Hint, it literally can walk you through the steps. So, and even tells you the answer. As long as you like read through it and understand it, you know, it's accessible to everybody. But all right, y'all, let's take a look at how to tackle some problem. Now, we don't have any bugs, but we can still use them to help us out. So we have right here, a limit as x approaches. Ooh, okay, I don't have little annotations. I guess I'm gonna have to write it. Okay, first things first is I noticed that all of these have 3 down here. So I know that the bugs are gonna have to stop at around 3. Next off, oh, there's something in the chat. Uh-oh. Yeah. Yeah. So I'm gonna go ahead and start to annotate. So this is what I do. So step 1 is I noticed, okay, the bugs are gonna be stopping at 3 again, which is nice because I guess we're used to seeing that 3. So this is what I'm gonna do. And these are the steps. I usually like to draw like a vertical line down through the X value of 3 like so. And then I'm gonna label my graph. So I like to label it so I'm just clear. Like this is the left hand side of my graph and this is my right hand side. So now I'm clear, kind of like what's my left, what's my right. Great. So this right here, my first question is, and I'm going to type it out at the bottom. I'm going to rewrite what this means. This means the limit as x approaches 3 from the left. That's what this is saying. So just a little reminder on what that means. So that means we're going to have to envision or imagine that a bug is starting on a curve on the left-hand side of this graph. So there's only one curve that's to the left of this line here, and it's this one here that looks like an upward facing parabola. So basically what I could do is place my bug anywhere on this curve. So I'm just going to place my bug right up here. You could have done her closer, him or her closer to the x value of 3. Doesn't matter, but I'm just going to imagine there's a bug right here, and that, let's just say this is Bertha. So that Bertha is going to walk along this curve, and she's going to stop once she hits that vertical line I drew at the x value of 3. All right, so let's see. So let's say this is Bertha walking here, and she's starting on the left-hand side, so that's why we're doing the left-hand limit. And she's walking, it looks like she's walking down a slope or down a hill, and then it's gonna go back up. Now, because Bertha can't fly or jump, she's gonna end up stuck again once she hits the x value of 3. So Bertha's gonna end up right here. Now, maybe some of you in the chat can tell me, but how high does Bertha end up in this particular instance? What do y'all think? So notice how I had to draw bugs. We weren't given bugs. We had to just draw them because bugs are going to help us. Yeah, look at this. I see 3 4s in the comments there. Y'all are right. So the limit as x approaches 3 from the left, the answer is 4. Y'all are correct. So notice if I were, for those who are like still trying to make sense of this, so what we do is just draw a dotted line to the height that Bertha ends up at, and the height is the y value of 4. So the answer to our limit is 4. Oh yes, don't forget, the bugs are too big to fall through the holes too. So that's another thing to remember. It was in yesterday's slide. So that was Bertha, cool. Now let's just pretend that for the right-hand side, we have Benny again. So let's again write our interpretation. So when it has a plus after our number, it means the limit as x approaches 3 from the right. That's what this means. And I'm just going to say this is Benny. So I'm going to be moving to the right-hand side of my graph. That's all of this section, but we're going to find where there's a function or a curve, and it's this one. It kind of looks like an upside down parabola. So we could place Benny anywhere on here, as long as he's walking and stops at the x value of 3. So I'm just going to put him all the way at the end here. So let's say Benny's over here. He's going to start here. And again, he's trying to meet up with his sister. He's going to go up a hill. And then he's going to go down. And then he's going to end up stuck again at the x value of 3. And now we want to figure out, well, how high is Benny now? What y value is Benny at? Let's see what y'all think. How high do we think Benny is at in this problem? At what y value is he at? Let me do some dotted lines, maybe to help as well. Okay, yes, we have three of us who are saying -3. Yes, -3 is right. That is where Benny ends up indeed. So the answer, -3. So that's how we're kind of figuring out limits when you don't have bugs. So again, when this shows up at Khan Academy, that's what we're going to do. Now, then what in the world do we do here? Look at this one. It has no plus or minus. So we're going to just put like, what the heck? keeping it PG. What the heck? So for this one, we're actually going to pause and wait until we learn what to do when you don't have a plus or a minus. So we'll learn that soon. But for now, we don't know. So we're just going to continue to practice the left hand and the right hand limits. So again, it's okay if you felt scared looking at that one. I'm gonna pause here and see. First off, does anyone have any questions? If not, we'll move on to further examples so we could get some practice in. All right, do make sure that you finished up your little annotations and your boxes or your comments on things to help. But again, we don't know yet how to do that last one. Maybe some of you have some ideas, but I'm gonna go ahead and start to clear the screen. And then we're gonna move on to, I think, one more example. I think, let's see. I'm just hoping I didn't do a repeat of this graph. I'm hoping it's a different graph. I feel so bad for Benny and Bertha. They just get no luck, still not meeting up. Okay, yes, this one's different. Okay, so this is going to be our last example practice with limits before we move on to a new thing, to the intro of the next thing, because, you know, we still have to tackle what do we do when the limit doesn't have a plus or minus. But here we got some here. So this one is interesting. Take a look. There's a lot of stuff happening in this function. It looks like 3 different functions first off, right? So we're going to try to talk about how we tackle this. Let's get some practice in. Okay, so first off, I noticed that when I'm looking at the questions I'm being asked, I noticed that it says x approaches -1. Then there's a plus after it. Then this other one says x approaches -1 again, but then there's a minus after it. So that means the x value that the bugs need to stop at is the x value -1. So I'm going to go to my graph and I'm going to start to now annotate it. I'm going to draw a vertical line down where the x value is -1. Now, is this something I do? Like me, I always draw lines? No. So this is actually something, it's crooked. So this is actually something I like in my head do. It's not something like I physically draw lines down it. So it could be in your mind. You're just envisioning that you're chopping this graph in half. And because we only care about what's happening at -1, we're still just going to have 2 parts of the graph. So this part is my left-hand side. And this part is going to continue to be my right-hand side. So right-hand side looks very funky. Left-hand side, pretty straightforward. There's only one thing there. So again, you draw your line down to where that x value is. Then you just separate what's left, what's right. Okay, so now let's go ahead and write down the interpretation. So this is saying the limit as x approaches, think of x like the bug. As x approaches, or the bug approaches, -1 from the right. We're doing the right-hand side first. It's gonna be a little bit tricky, but we'll do it. We got this. Okay, so we got to place our bug somewhere. Now, the tricky part is we have a lot of stuff happening on the right-hand side. We have this middle part, and we have this curve down here. So how you choose where to place your bug, and let's say that this is going to be Benny again. Let's just say Benny's always starting from the right. How you choose where you place your bug is your bug has to stop at the x value of -1. Notice how this curve down here, it doesn't even reach the x value of -1 over here. It kind of just gets cut off down here. So therefore, we need to place Benny on the curve that does end up having a pathway to -1. So that means I'm going to place Benny right here. Benny starting on the right-hand side of the graph, but he has to start on a line or a curve that's going to reach the x value that he needs to stop at, which is -1. Let me know if anyone has any questions on why I put Benny right here. And again, it can't be this one because it does not reach the x value of -1. Okay. All right, so then let's envision Benny walking. So he's gonna walk, walk, walk. Remember, he can't fly, he can't jump. It's not like he's gonna jump up to this little closed dot and jump back down. He can't. He also can't fall through this hole. He's too big for that. And he's just gonna now walk on a straight line. And he's gonna end up stopping once he hits the x value of -1. So there's where Benny ends up. He's now once again stuck up here. And now we're gonna ask ourselves, how high is Benny once he's at the x value of -1? What y value is he at? All right, Zion, yes. We got a direct message saying 2. Y'all are right. Danny's in agreement. That is true, yes. The limit, as x approaches -1 from the right, the answer is 2. And again, that's just using bugs as a tool to help us. If you go to college and you're like bugs, they'll be like, what? That's just a tool. Don't worry. Over time, once you get your practice, you'll be able to tell. You'll be able to do this with fluidity without having to talk about bugs. But right now, we could use bugs as a tool. No problem. Yes, we're all in agreement on 2. Awesome. Okay, so that was for the right hand side, but now we're being asked to find the limit as x approaches -1 from the left. So let me just write down the interpretation. The limit as x approaches -1 from the left. And again, remember, we know right and left because right means there's a plus after the number, left means there's a minus after the number. Well, left-hand side is going to be pretty straightforward, and we're going to say this is Bertha. The reason why this is straightforward is we only have one curve to the left on this graph, to the left of -1, or to the left of the line I drew. There's only one curve. So I'm going to go ahead and place Bertha there. Like, here you go, Bertha, you're there. I see something in the comment. Haven't opened. So it looks like Bertha is going to just walk up like a little slight hill. She doesn't have as much traveling to do. And she's also going to get stuck. And she's going to be right on top of this open circle. And she's going to get stuck at the y value of, yeah, Danny puts 1. That's true, yes. Bertha's going to end up at the y value of 1. And for those who can't see that, let me just draw a little dotted line. That is the y value, or the height, that Bertha ends up at. So this is Bertha, that's Benny. Hey, they didn't meet here, but hey, maybe they're close enough to at least talk. They could at least yell down to each other. So the left-hand limit is going to be the value of 1. Again, in reference to what you all just said in the Padlet, some of you are saying they're not going to meet up because they're at a different height. That's the case here. They're not going to meet up because their limits are different numbers. See how 2 does not equal 1? So this all correlates to what you all wrote in the Padlet. So pretty cool. And that's going to conclude the practice with limits. And we're going to transition into the next portion. So let me know if anyone has questions, though, or needs to get any final parts of this jotted down in your annotations on your slide, not on your notes. But if you're doing notes, it's okay. Okay, let me clear this up. Okay, y'all. So we're going to transition to just get you to think about what we're going to talk about in our next class period, which is going to be on, wow, tomorrow's already Thursday, right? That's crazy. Tomorrow. So yay. All you got to do is I'm going to show you a video, and that's going to be the end of class. So don't leave. Please watch the video. So I want you to think about, because there's going to be times when a limit doesn't exist. So that's just something to think about. And we're going to investigate, well, when doesn't a limit exist? All we learned about was left hand limit, right hand limit. We learned and talked about Benny and Bertha. I'm going to show you this little clip from Mean Girls. Now, y'all, I had never seen this movie. So I don't really know it. I mean, the only reason I'm choosing it is because there's like a limit thing in here. And maybe y'all will be able to understand. Is it a good movie? I don't know. Yeah, someone has seen it. Oh my gosh, two of you have seen it. Everyone's saying I should watch it. Okay, let me go ahead and refresh memories then. Okay, let me play this clip.
Contestants, find the limit of this equation.
Calling somebody else fat won't make you any skinnier. Calling someone stupid doesn't make you any smarter. And ruining Regina George's life definitely didn't make me any happier. All you can do in life is try to solve the problem in front of you.
The limit is -1.
Oh, crap. I lost.
That answer is incorrect. Now, we are in a sudden death. If Miss Heron can answer this problem correctly, we have a winner.
Limits. Why couldn't I remember anything about limits? Limits. That was the week Aaron got his haircut. Oh, God, he looks so cute. Okay, focus, Katie. What was on the board behind Aaron's head? If the limit never approaches anything, the limit does not exist. The limit does not exist.
Our new state champions, the North Shore Mathletes.
How do you like me now? You like that?
Okay. Okay, I think that was enough of that. Okay, cool. Seems like a funny movie. Okay. I did not get that far to the next one. So this is something to think about. And again, I picked this out because there's a mentioning of limit not existing. There was something behind that teacher's board. She was drawing something. But for now, I'll leave you off with what we just watched. And that's gonna be our checkout today. So just think about this. When do you think the limit doesn't exist? And that's our checkout, y'all. You don't have to write this down. I'll see you all tomorrow. Y'all have a great day. At the end of our class, y'all. It's gonna help us for tomorrow. But bye, everyone. Enjoy today. I do have office hours in case anyone needs to meet up for anything. Otherwise, bye. Bye, AJ. Bye, Danny.